You know that feeling, right? You ask an AI a pretty simple question, and it gives you this incredibly confident answer that turns out to be completely made up. Well, today we're going to get to the bottom of why these super powerful tools sometimes, well, lie. We're diving into a really fascinating paper that explains this very strange and, let's be honest, frustrating phenomenon.
All right, so to really see what we're talking about, we did a little experiment ourselves. We took a few of the biggest AI models out there and asked them a really straightforward question. It's about Adam Kalai, the author of the very paper we're digging into today. The question was simple. What was the title of his PhD dissertation?
And wow, here are the results. Check this out. GPT-4o comes back with this super specific, official-sounding title. DeepSeek, it doesn't just give a title, it throws in Harvard and the year 2005 for good measure. Llama does pretty much the same thing, but with MIT and 2007. They all sound so sure of themselves, right? Here's the kicker, every single one is wrong. Just completely made up. And not just the titles, the universities, the years, all of it. Total fiction.
So this whole thing has a name. It's called an AI hallucination. And look, this isn't just some minor bug or a funny quirk. It's actually one of the biggest problems we're facing with these systems because it totally undermines our trust. I mean, think about it. What good is a super smart assistant if you have to second guess everything it tells you?
Okay, so why does this happen? Is the AI just losing its mind? Is it glitching out? Well, the paper we're looking at says nope, not at all. This isn't some random mistake. In a weird way, it's actually a predictable, almost unavoidable consequence of how these things are built from the ground up.
And to help us wrap our heads around this, the paper has this absolutely perfect analogy. It says, don't think of an AI as some all-knowing oracle. Instead, picture a student who's cramming for a huge high-stakes exam. Now, what happens when that student gets to a really tough question they don't know the answer to? They don't just leave it blank, right? They guess. They try to write something that sounds plausible, something that might just get them some points.
So, the root of this problem goes all the way back to the very beginning. It starts in what's called the pre-training phase. You can think of this as the AI's study period, where it just inhales this gigantic, mind-boggling amount of text from the internet. The goal is for it to learn all the patterns, the grammar, the facts, the whole shebang of human language.
Now, this is where it gets really interesting. The paper points out something that feels obvious once you hear it. Generating a correct sentence from scratch is way harder than just spotting if a given sentence is correct, right? It's much easier to tell if a paragraph is well-written than to actually write it yourself from a blank screen. And it turns out this distinction is crucial because the AI's training is tied to that easier task, and that has massive consequences down the line.
And that brings us to the nerdy math part of it, but stick with me because this is the core of the whole thing. The paper shows there's a direct mathematical link here. Basically, the rate at which an AI will generate an error is guaranteed to be at least twice as high as the rate at which it fails to spot an error. Let me say that again. If an AI is just a little bit bad at recognizing a falsehood, it's going to be at least twice as bad at avoiding making one up itself.
So let's just put that in simple terms. If a model has even a tiny bit of trouble telling fact from fiction during that initial study phase, that weakness gets magnified, it gets amplified when it's asked to create new sentences on its own. It means this pressure to guess, to hallucinate, it's literally baked into the system from day one.
Okay, that makes sense for the beginning. But you might be thinking, wait, don't developers spend like a ton of time and money fine-tuning these things to be more accurate? And you're right, they do. So why do these hallucinations stick around? Well, that brings us to the next part of the story, the post-training phase. If pre-training was the study phase, this is where we teach our student AI how to actually take the test.
And here's the crazy part. It turns out the exams we give these AIs, they actually reward them for guessing. The models are always in what the paper calls test-taking mode. And on these tests, there's a huge penalty for admitting you don't know the answer.
And don't just take my word for it. The evidence is right here, and it's kind of shocking. These are some of the biggest, most important benchmarks used to grade and rank AI models. Just look at that column on the far right. What do you see? Benchmark after benchmark. The main score is all about accuracy. And the credit for saying, I don't know? Zero. Zilch. Nada. You get no points for being honest about your own limitations.
So what's the effect of all this? It's stark. These charts show something called calibration, which is basically a fancy way of saying how well the AI knows what it knows. On the left, before all this test prep training, the model's actually pretty good. Its confidence generally lines up with how accurate it is. But now look at the chart on the right. after being trained to ace these tests, it just becomes wildly overconfident. It starts screaming with certainty about answers that are just plain wrong.
What this all means is that we've essentially and unintentionally trained our AIs to be really, really good bluffers. The paper calls it an epidemic of penalizing uncertainty. And it's exactly like that student taking a multiple-choice test where there's no penalty for wrong answers. What's the best strategy? Never leave a question blank. Always, always guess.
Okay, so this sounds pretty bad. How do we fix it? Well, this is the best part. The paper proposes a solution that is so simple and elegant, you'll wonder why nobody did it before. The idea is, stop trying to build these super complicated hallucination detectors to clean up the mess afterwards. Instead, just change the rules of the game. Fix the tests that are causing the problem to begin with.
So here's what that looks like. First, you change the tests. You actually add a penalty for wrong answers. Remember how the old SATs used to do that? That immediately makes just guessing a terrible strategy. Second, you just tell the model what the stakes are, right in the prompt. You say something like, hey, only answer this if you are over 90% confident. And just like that, you completely change the incentives. You start rewarding the AI for being honest about what it doesn't know, instead of for bluffing.
And that really leaves us with a bigger, more provocative thought, doesn't it? Our AIs are, in a way, a reflection of what we value. And if we set up a system that only rewards confident-sounding guesses, well, then we're going to get a world full of confident AI bluffers. But if we change how we measure success, if we start rewarding honesty and a healthy dose of I don't know, we can actually steer this entire field toward building AI that we can truly trust. It makes you wonder, what other biases and values are we accidentally teaching our technology right now?